Hi everyone, this is just a quick little video just to help with some practice of unit conversions from the worksheet in your booklet. So just going to go through a couple of quick examples to help build your skills with this and give you a little bit of extra confidence in how you're going. So I've just selected a couple of questions that I'd like to work through just quickly. Alright, so let's start with question 1. Okay, so we're told that you've got 74 centimeters and we want to convert that to a value in meters. And so what we are going to do is we want to use a factor that's going to give us, that has the units we want of meters over the units we have of centimeters. Okay, just like we've been working with before, so that our units of centimeters will cancel out. So what we can see from our sheet is that, and we know quite intuitively, that for every 1 meter we have 100 centimeters. That's how we would convert between these two things. Okay, our centimeters will cancel out here. You put that into your calculator and you end up with 0.74 meters. Okay, so the key thing here is in recognizing the size of the number that we need to make these conversions. So from the sheet in your booklet, I understand it's a little bit confusing sometimes with the scientific notation. For some it looks a little less familiar, and also, you know, they're all expressed in units of length. When the question that you're dealing with may not be that. So just remember that we're looking at what the prefix is, the size factor, you know, kilo or mega or milli or centi or whatever. Okay, so you keep your focus on that. Alright, let's have a look at number 5. Okay, so this is where the scientific notation starts to kick in a little bit more. But also that can be, you'll see that actually can be quite helpful when you're wanting to do these sorts of things. So you've got 9.52 times 10 to the minus 4 meters, okay, and we want that in a value of these things called micrometers. Okay, so this is the Greek letter mu, which is the letter M, and so it's like a U with a kind of the front, like this front tail sort of bit, and so this is what we're going to be finding. So we're going to need to be multiplying the number that we've got here by a factor that's got the units we want over the units we have. Okay, and so what we're saying is that for every 1 meter that we have, looking at our factors, we have 10 to the power of 6, that is 1 million micrometers. Okay, and so what we're going to do, then we can get to put this into our calculator, and we get 9.52 times 10 to the power of 2 micrometers. Now, if you have a quick look at the scientific notation here, you see that I've had minus 4 over here, and 10 to the 6 plus 6, and then I end up with 2. So what that means is I've basically added these indices together. I've taken that it's 9 point, because this is just a size of 10, that I've gone from minus 4 and I just add 6 onto it, and I end up with 9.52 times 10 to the power of 2. So it's actually deceptively simple, because we're dealing with powers of 10 conversions. Okay, so number 7. Okay, so you've got 6.0 times 10 to the minus 1 grams. Okay, and so then we're asked for a value in milligrams. Okay, the factor with the units that we want, milligrams, over the units we have, grams. So for every 1 gram, we know we have 1,000 milligrams. Okay, but I could also write that as 10 to the 3 milligrams, because 10 to the 3 is the same as 1,000, 10 by 10 by 10 over 1 gram. Okay, so I put that into my calculator, 6.0 times 10 to the 2 milligrams. Okay, now what I'm going to look at is question number 10. Now, so 10, while dealing with units that are perhaps a little bit more familiar as far as looking from, how many seconds we have in one day, this shows for me some of the power of the factor label method. The ability to daisy chain or connect in sequence a number of different factors to go from one unit to another. And you'll see there's a couple of examples you need to do that in these exercises, that you can't convert easily in one step. You convert to the kind of a base unit of a meter or a gram or something like that, and then you convert again using a different factor. Okay, so we have 1 day. So in this case, we've got 24 hours in 1 day, okay, leaving us units of hours when those cancel out. And then we want to say, all right, well, I want to work that into minutes. So 60 minutes for every 1 hour. So I've now got units of minutes. I want to turn that into seconds. 60 seconds for every 1 minute. My minutes cancel out. So I've cancelled everything through except the units of seconds at the end. And then I just put into my calculator, I can put 1 times 24 times 60 times 60, 86,400 seconds when I follow through that process. Okay, so you can see that I can, because at each stage all I'm doing is the next factor has the units that I want for the next step over the units I have at the current step. Okay, so it takes a little bit of a fraction more planning, because you have to try and see through from where you are to where you need to be, which may not be immediately apparent. So you kind of have to be a bit careful there. Alright, then the last question that we're going to deal with, and I can't remember what question number it is, so you'll just have to figure it out. Be big boys and girls. Okay, so you're given a value of 9.1 times 10 to the minus 13 kilograms, and you're asked for a value in nanograms. Okay, so this is one of those examples where you're going to have to multiply by 2 factors. You could do it in 2 steps, or you could connect it in one line of working if you're confident with what to do. Okay, so let's go from kilograms to the base unit of grams. So I've got the unit I want, grams, over the unit I have, kilograms. I have 1,000 grams for every 1 kilogram. So I would get a value in grams. But now I'm going to use this same principle as we had here. I'm going to connect together another factor that will take me from grams, the units I have, to nanograms, which is the units that I want. Now when I look at going from here to here, I have 10 to the 9 nanograms for every 1 gram. Okay, so my kilograms cancelled from here and here, my grams cancelled from here and here, and now I have units of nanograms as my final response, final answer. And so I end up with 9.1 times 10 to the minus 1 nanograms as my final answer. Okay, so interestingly, the same sort of approach that we followed before. Now, because remember that 1,000 could also be written as 10 to the power of 3, so if I kind of rewrote that just for argument's sake here, what I've done is I've got 10 to the minus 13, and then I'm adding on 3, so 10 to the minus 10, and I'm adding on another 9, which makes it 10 to the minus 1. So I don't actually, because of these conversions, I don't actually need to calculate anything. I can use this principle, and off the top of my head, just be able to, all I'm changing is this area of the scientific notation. That didn't apply here in number 10 because I wasn't dealing with pure powers of 10. I had to, actually perform the calculations at each step. But here, with a bit more confidence and a bit more know-how, you can do these calculations in scientific notation form very simply. Alright, so there's five of the questions that you're asked to work with. Hopefully that gives you a little bit of extra guidance and a bit more reinforcement to go on. If you've got any questions, you always come see me, let me know, and I'll help you out as much as I can. Alright, thanks for watching. Bye for now.